So yes, Ragul, first of all, tell me your favorite subjects.
Yes, sir. Chemical reaction engineering,
Hmm.
heat transfer, mass transfer, and fluid mechanics.
Okay. Moving towards chemical reaction engineering, why it is named as chemical reaction engineering?
Chemical reaction is a basic thing that actually happens in any chemical industry. Even you take chemistry, people also read chemical reactions about chemical reactions. But particularly, we engineers are concerned with determining what will be the size of the reactor and what are the operating conditions will maintain. So it's more related to engineering way, but they do something in laboratory way now, like bench scale they will do. So they also read chemical reaction, but we are now more engineers are more concerned a separate thing for like how much amount of operating conditions you made, like temperature, pressure, and what are the what are arrangements like for what you do for heating, what you do for cooling. Suppose you have unrated reactor, which how you separate it. So we are more engineering aspects comes more into when you go for such kind of reactor design. So we name it as chemical reaction engineering. Sir.
Fine. So tell me about what is chemical reaction basically.
Yes, the chemical reactions are generally concerned with the transformation of one type of suppose elements like group of elements. You have suppose one molecule that actually suppose you take carbon react with oxygen to form carbon monoxide. Here a group of elements actually in the form of molecule which combine to form another molecule. That is what actually a chemical reaction. Simply we say that a reactants getting converted into products.
Okay.
Rearrangement is there because of the formation of new bonds and breakage of new bond. That is actually chemical reaction. Chemical reactions are usually concerned.
Okay, fine. No problem. Give me a second. Okay. So Ragul, moving towards the very basic question I would like to ask you. How many types of chemical reactions are there?
Types of chemical reactions like we can classify basically as a homogeneous reaction, heterogeneous reactions. Homogeneous reaction usually occurs in single phase. Heterogeneous reaction actually takes place in multi-phase. Like when you say gas liquid reactions, gas solid reaction, they are heterogeneous reactions. So there we have additional mass transfer step in addition to chemical reaction kinetics. But in case of homogeneous reaction, we'll have only the reaction step. We don't have any mass transfer step.
So tell me, what are the applications or what are some such concepts that do we use in mass transfer of chemical reaction engineering?
Okay, you are asking chemical reaction concept we used in mass transfer.
Yes.
Yeah, yes, sir. Suppose we consider we do absorption. Absorption is nothing but is a process in which we remove a solute from particular gas mixture by bringing contact with the solvent. Suppose you consider that in that like suppose if that absorbed solute undergoes a reaction with the solvent, then you have the greater recovery of the solute from the gas system. So you will have here you have the concept reaction engineering also now comes into play, right? Like how this here you have combined reaction as well reaction step as well as mass transfer step. So here actually reaction step actually is now enhancing the mass transfer operation.
Okay, fine. That was a nice answer. I would suggest. I would like that. I have liked that. Okay. Okay. Tell me, as you said, adsorption. So, how many types of adsorption isotherms are there?
Um, for example, adsorption, single layer adsorption, then you have multi-layer adsorptions. Like we say, single layer adsorption means
I'm
a
not saying
Langmuir adsorption.
types of adsorption. I'm saying types of adsorption isotherms. I said.
Yeah, yes, so there are 5 types of adsorption isotherms. Like
Yes.
monolayer adsorption, multi-layer adsorption. And after that, suppose adsorption taking place any kind of capillary like that. Then after that, we will have some adsorption as well as this a concave and convex such kind of arrangement will be there.
You must be aware of Langmuir adsorption theory, right? Are you aware of it?
Yeah, yes, yes.
Tell me.
Yeah, Langmuir adsorption isotherm, it's a single monolayer adsorption isotherm, sir. It just involves van der Waals force of attraction between the molecules. Suppose you consider that you have adsorbent, you have adsorbate. simply it assumes that the sides are actually equivalent to one another. There is no movement between the sides. And see, once the molecule get adsorbed on the side, they do not actually interact with the other molecule in the sides. Then we say that adsorption here, actually rate of adsorption is directly proportional to the how much amount of side that is actually vacant, and it also depends upon the partial pressure of the gas or solute, concentration of solute.
Can
Then
you
the rate of
write,
desorption.
explain, can you write the equation and then explain? It is
Yeah,
going,
yes.
yes, please do.
Can I see?
Yes, PA, what's the, why adsorption is directly proportional to PA into 1 minus theta and YD is directly proportional to theta, right? Okay. This is the theory, okay? This, it is a statement, right? Tell me
Yeah.
the law. I want the law. Adsorption isotherm law and the graph. The
Okay.
you know the graph is plotted between,
But
the graph is plotted between.
yeah.
Ah,
Graph is now plotted between. You actually have the form fractional. The theta is equal to kb bar by 1 plus kb bar. That expression we have.
hmm.
Then we plotted theta versus that partial pressure.
Yes. Now great.
Then then we have high about a partial pressure, means then it is going to be acting as a zero order system, like that. It depends upon only independent of the partial pressure. When you have low at a low concentration, that is low partial pressure, it is going to actually approximate first order behavior. It depends upon the concentration of the adsorbent.
Fine. Okay. Moving towards next question. You said mass transfer, right? You are going to say about mass transfer even, right? What are types of trays? What is a tray?
Okay, yes,
Tell me what is a tray, and then moving towards
yeah,
type.
yes.
Yes.
Yes, a tray usually considered as an heart of the column. Why we say is because in the tray only we bring the two streams into contact. Like say we say gas phase or liquid phase into contact. For example, simple say absorption, we bring the gas and liquid phase into contact and allow the exchange of material to take place from the gas phase to liquid phase. So actually, the mass transfer actually taking place only in the trace. It actually trace ultimates it is a region where actually we make the provision for mass transfer to take place by bringing the contact between the phases. So entire performance of the column itself now depends upon the efficiency of the tray.
Yes. So tell me, what are the types of trays?
Yes, so we have sieve trays, wall trays, and bubble cap trays.
Only three are there.
Yeah, yes, sir, there might be other types also.
But you remember three only, right?
Yeah, yes, sir.
Okay. So tell me, in packed towers, do we use tray?
In packed towers.
Yes. In packed towers, do we use tray?
No, sir.
What do we use there?
Here we use packing materials, sir. Actually, we have distribution plates between one plate is actually for this entry and then exit. You have distribution plate. One is for distributing the solvent over the packing material. Between these two plates, we have the packing material now.
Achha, you have packing material. So what type of packing material is there provided?
Yes, sir. Packing materials are we have two types of packing. One is random packing, other is structured packing.
Yes.
Random packing comes you have first generation packing, second generation packing, third generation packing we see. But what I say random packing means simply you take the packing material, dump into the column. That gives a random orientation of the packing material. That is called random packing. For example, we can say random first generation packing, we have rashing ring, lacing ring, bulb saddle, cross partition. Like second generation packing, you go means we have interlock saddle we say. And then we have fall rings, plastic tellurate like that we say. Third generation packing, if you go means we have tri-pack, north pack, such kind of things we have. When you go for structured packing, it's mostly simply a corrugated structure arrangement. Like corrugated structure now. Like such kind of sheets, corrugated sheets, what we call it as structured packing. When you compare this random packing and the structured packing usually have give low pressure drop, and that is the way advantage of structured packing over the random packings.
Random packing. Low pressure drop is there, right? Okay.
Yeah.
So which is cost efficient?
Cost efficient in the sense actually structured packing will be consuming a high cost, sir.
High cost. And tell
Yeah,
me
yes, sir.
tell me about the scenario of maintenance cost.
Yeah, when you go from maintenance cost, that will be very high in random packing
Random packing
because
will
I
have
don't
maximum.
tell a high amount of maintenance cost, sir,
Okay.
compared to structured
So
packing.
chalo, fine, no problem. So can you just draw the graph of optimization of this optimization? Are you aware
For for what, sir?
for this trace, like uh, the optimization curve I want, like in
Trace
that,
stability, the
yes,
region of operating like that you are
yes,
saying.
yes.
Okay.
Which one you are saying? The not that one I'm asking you, okay? Like which one? Down the flooding one, that one I'm not asking, right? The curve
Okay.
which I'm asking of the I'm not remembering. Give a second.
Like
In which variable cost, fixed cost, and total cost is there? That graph I'm asking about.
in distillation, you are asking. Like,
Yes, in distillation itself. So I'm talking about distillation only.
okay, okay.
Oh, just remember, the word is not coming in my mouth. Oh, yes. Anybody just comment drop a comment what that graph is known as? Optimization one, in which the total cost is minimum.
Sir,
Yes, fine. This one only. Okay. So operating operating cost is here, fixed cost is here, total cost is here. Okay. So you say, there is one point at which the graph or the parabola you have drawn at the minimum point, right? What that point is called as?
total cost. For total cost, you are
Yes,
asking.
what total cost itself.
Yeah, that is the optimum reflex ratio, sir. Because you will have some kind of compensation with the uh, both the operating cost and then fixed cost. They come to minimum value, a particular value of reflex ratio. That reflex ratio, what called optimum reflex ratio.
Okay, so tell me, like, why do we use only optimum reflex ratio? We are like minimum reflex ratio, we can find out directly, right? XD minus Y dash upon Y dash minus X dash. But still, we use optimum reflex ratio concept. So why?
Yeah, yes, sir. Well, if I go for optimum reflex ratio, even though we have very low value of operating cost, but what will happen is number of trays that actually required in this case will be very very high. So it may just go even to very large number of trays, like infinite number of trays you require for that event separation. Because when you say we're doing the enrichment of the vapor with the more volatile compound now. So liquid phase has to now come in contact with the vapor phase. So we allow the diffusive transport of this more volatile component from the liquid phase to vapor phase. For that, the right amount of the contact between the phase needed. Suppose when you have very less amount of reflex coming into that contact with the vapor phase, then such kind of enrichment will not be proper length. So we have to now increase the number of trays. I
Okay,
think and
yes, you're right itself. No problem. You're right. Okay, Rahul, the last question I would be asking you. I am
hmm.
designing, I am designing a tray tower, right? I am designing a tray tower. Okay.
Okay,
Now,
sir.
now I want to calculate the size of tray.
Okay.
Size of tray बोलूँगा नहीं. Tell me.
Size of the column.
Mhm. Size of the column, not size of the column. I want downcomer area. Okay, I want downcomer area. So
Okay.
how would I calculate the downcomer area?
It's a downcomer area as a thumb rule. It is taken as a 10 to 12% of the total cross section areas. if you know diameter of the column, then if you find total cross-section area, so as a thumb rule, we give usually total downcomer area, both downcomer top area and downcomer bottom area. That sum will be actually equal to 10 to 12% of the total cross-section area of the tower, sir.
Okay, so tell me about
If you
downcomer and weir. Okay, how they are different, downcomer and weir. Can you draw and elaborate?
yeah, yes.
Yes. Downcomer and weir. Tell. Explain now.
Okay,
It's
down.
it's not visible. It is blurry. Keep it far. Keep it far. Keep it far.
Okay.
Yes, yes, it's visible now. Yes, downcomer is here. Weir is there. Okay. So why weir is provided there? Why weir is provided?
I, yes, sir, we have to maintain certain pool of liquid over the train. Then only we'll have the contact between the
Yeah.
vapor and liquid. Suppose if we just simply allow all the liquid to run down, then it will cause downcomer backup flooding. More and more of the liquid will go in the downcomer, so will not actually that liquid now. So it may actually lead to flooding also sometimes. So simply just downcomer weir is actually provided to maintain certain pool of liquid over the train, so that gas actually bubbles through that, and we'll have the good amount of vapor liquid contact.
Fine. That was a very.
Mainly simply is to ensure certain amount of liquid, sir.
Manish, have I asked
Downcomer
you?
is a region.
Manish, have I asked you? Please be quiet. Yes, Raghu.
Uh, downcomer is the region through which the liquid crystalline engagement takes place. In fact, so from the top to bottom train, that passage through which fluid actually is flowing is at least only downcomer. That region what we call downcomer. But weir is a simply structure which actually provided to ensure a certain amount of liquid is actually stayed over the tree.
Yes, fine, fine. I got you. I got you. Okay, so fine. It was a very impressive interview. You are going to crack Barc technical officer. It's a technical officer interview. That's for sure. Just
Okay.
you got nervous. You last in the last mock also. I told you that you get nervous, right? You lose patience. See, it's 25 minutes only. You lost patience, right? Don't lose
Okay.
that. You are losing patience.
Okay.
Nobody can stop you in technical. Even the interviewer is not going to stop you for technical. Okay. The thing which is the patience and nervousness. Why are you feeling nervous in the start? In the start as in the at the start of the interview, I told you that please come in formals. That's why you got panic there.
Yeah.
Hmm? That things are going to happen there itself. Suppose it had happened with me also. I was really very panic for my document verification once in NPCIL interview. Okay.
Okay.
Okay, so it happens. What they say, like suppose there are many situations like Xerox is not there. Okay, they do not provide Xerox, so we have to go to some other location like 1.5 or 2 kilometers. It's far from the Barc, sorry, Barc Anushakti Nagar. It is very far. 2 kilometers is far from Anushakti Nagar. That Xerox centers are there, right? So sometimes we do not have as
Yes, sir.
single Xerox also. So the things happen. So you do not have to take such panic situations. Are you getting? Many situations arose. There are many people like
Okay.
suppose 1 or 2 documents also left. Okay, there are people with me also. One time it had happened, right? My EWS certificate was not made. Okay, it was not made. I went.
Okay.
Okay, I went. Then actually the rule was something different, right? But then I got the EWS certificate, and then I was able to give the mock interview even. Okay.
Okay.
So there are many cases. So you do not have to panic for such small things. Okay. Technical knowledge, you are having awesome command in technical knowledge. Okay. You just clear the interview and just join Margdarshan team. After that, you are going to guide other students as well of chemical engineering. Okay, so give me a second.